Hi, grade 11s. Today we're going to take a look at exploring quadratic relations. We've already looked at some basic properties of quadratic functions. Today what we're going to do is we're just going to learn about some more and give us a little bit more of a complete basic view of quadratic functions and relations. So, one of the important things I need you to be in your textbook at section 7.1, exploring quadratic relations, because you're just going to follow along in your book and maybe do a little bit of work with a graphing calculator or Desmos and maybe write down some stuff, not in your book, on a piece of loose leaf. So, one of the very important things that's at the beginning of section 7.1 in your book is that the standard form of a quadratic relation is y equals ax squared plus bx plus c. A has to be something other than 0. B or C could be 0, but A can't be. If A is 0, then we don't have a quadratic relation. Then we're talking about a line. So an example of such a relation is y equals 4x squared plus 2x plus 1. And what we're going to look at today is what happens when we change the values of A, B, and C to the quadratic. Now I know that not everybody has Desmos, but using Desmos is the easiest tool for me to show you how to do this. So I'm going to go to Desmos and we're going to look at this, okay? So I'm going to type in, and you can do this too if you have Desmos, but really I want you to watch more than anything, because the watching is the important thing. Y equals ax squared plus bx plus c. We're going to add all those three sliders, okay? I'm going to let b equal 0. Actually, no, I'm not going to. I'm going to let b equal 1. That's fine. No, whatever. I'll make that be 0. And I'll let this be 0 too. So we want to look at individually the effect A, B, and C have on the graph. Okay? So I want you to look at what happens to the red quadratic as I make A bigger. So I'm going to make A bigger right now. As I make A bigger, what happens to the graph? As I make A bigger, the graph becomes stretched. Okay? It becomes stretched or skinnier. Okay? So as A gets bigger, the graph gets stretched or becomes skinnier. So I would write that down. Okay? So I'll repeat that again. As A gets bigger, the graph is stretched or becomes skinnier. Now, if we decrease the value of A, the graph becomes compressed. Or another way of looking at it is the graph becomes fatter. So the graph is compressed vertically or becomes fatter. Now, if I make a negative, woo, we see something special. If a is negative, the graph points down. So for all our other ones, a was positive and the graph pointed up. So if a is positive, the graph points up. If a is negative, the graph points down. And the same thing is true. Ignoring the sign, as the value gets bigger, the graph becomes skinnier or stretched. If the value gets smaller, again, ignoring sign, the graph becomes compressed or looks a little bit fatter. Okay, that's the effects of changing the A value. Let's take a look at what happens when we change the value of B and C. If we increase B, and I can press this play button. If I increase, ooh, that's fast. Holy jumping. I'm going to start right here. Let's try and do this right here. As I increase B, the graph moves left and down. So if I increase B, the graph moves left and down. That's what happens when I increase B. The graph moves left and down. It isn't stretched or compressed. It's not skinnier or fatter. The shape stays the same. But if we make B bigger, the graph moves left and down. Now, what if we make it smaller? If we make it smaller, the graph moves right and up. But that is only true when B is positive. When B is negative, we look at it a little differently. So when B is negative, as B gets to be a bigger negative, the graph moves right and down, right and down. If B is negative and it becomes closer to 0, the graph goes left and up. So what's important to see here is that if we change the value of B, the graph is going to move horizontally and vertically. And depending on whether B is positive or negative, it's going to go in opposite directions. Okay? B's kind of tricky. We're going to look at different forms of a quadratic relation where it's a little bit easier to see, but not yet. But what we can definitely see is that as we change B, it'll have a vertical move and a horizontal move. C is a little bit more straightforward. It's a lot more straightforward. As we increase C, the graph moves up. If we decrease C, the graph moves down. And that's always true. If C goes down, the graph goes down. If C goes up, the graph goes up. The shape doesn't change, and there's only one type of movement, up or down. And if C gets bigger, it's up. If C gets smaller, it's down. Okay? Okay. So, under the reflecting page or part of this, it says, describe the common characteristics of the parabolas you graphed. In other words, what's true in all these? Here's what we know about a parabola. And we talked about this during the last lesson, but it deserves a little bit more attention. There's either a maximum or a minimum value. They always open up or down, and they're all symmetrical about an axis, fancy word for line, that passes through the maximum or minimum point, otherwise known as the vertex. So in other words, if I have a parabola that looks something like this, the axis of symmetry is going to pass through the center of it. Okay? Part B. Describe the symmetry in the graphs. The turning point, which is a fancy word for saying the vertex, is where the line of symmetry is. So where that max or min point is, that's where the line of symmetry is every time when we draw or look at a quadratic. So if you're going to draw a quadratic or a parabola, whatever you want to call it, there's always an axis of symmetry, and it always goes through the vertex. Part C asks, are these quadratic relations that we graphed functions? Yes. If you recall from grade 10, a function is a function if we cannot draw a vertical line and cross through the graph in two spots. So I'm going to draw a vertical line here. That's not what I wanted to do. Sorry. This is what I wanted to do. I'm going to take this vertical line and I'm going to pass it through the whole graph. And never once do I pass through the graph in two different spots. So yes, everything we've looked at here today is a function. Part D, what effect does changing A, B, and C have? We've already talked about that. We've already talked about that. So, the graphs of three quadratic relations are shown. Predict possible values of A, B, and C. A is a tough one because it's hard for us to know what this graph looks like. So I'll just give it to you for now. A is 1. Then we have to ask ourselves, how is the graph moved? Well, we move it, it's not moved left or right. It's just moved down 2. If it's just moved down 2 and that's it, then B should be 1 or 0. B should be 0. And C, because it's moved down 2, C should be -2. And it is. Understand that when we know so little about this stuff, it's really hard to figure out these values of A, B, and C. As you get more comfortable with how a quadratic looks, then you'll be a lot more comfortable with figuring it out. This next one, well, I'm going to tell you again, A is 1. So the trick is B and C. This has just moved to the right. But remember, we said we moved right and down. Right and down, and then to get back up, we'd have to make C positive. So I'm not sure exactly what it could be, but I'm thinking B is going to be some positive number. And C is going to be, actually, I lied. We could make B negative. We can make B negative. Yeah, we can make B negative. And we can make B negative, and we can make C positive. So B could be negative. Let's say B's, I don't know, maybe -4. Yeah. So B's negative. And C, we're going to have to go up some. C is going to be +4. So that's what that's going to be. And again, I don't expect that you're going to get these with what we know so far about quadratic functions. But as you familiarize yourself more with these throughout the unit, you should become more proficient at this. Should. Okay. And now we'll look at this guy. What's it going to be? Well, from the last one we did, because it's also, like this is at 2, and this is at 2. So I'm going to say A is 1, and I'm going to say B is -4 again. But I'm going from being on the x-axis to up to 3. So that means it has to be 3 more than this guy. So I'm going to say C is 7. Ta-da, C7. Okay? So even though we might not be able to pick up everything, there are some things that we should be able to pick up as we cycle through these questions. Okay? So now we're just looking at summarizing what we've talked about here with quadratic functions. When we talk about quadratic function, we might want to talk about the degree. In grade 9, you should have talked about the degree of a polynomial. Basically, the degree. Hang on a second, please. Okay, sorry about that. The degree is the highest exponent in a polynomial. The degree of any quadratic function, anything that looks like a parabola, is always going to be 2. Standard form of a quadratic function is written in the form y equals ax squared plus bx plus c. And the only thing we say is that a has to be something other than 0. Could be positive, could be negative, could be a fraction, could be a decimal, just can't be 0. And the graph of any quadratic function is a parabola that has a single vertical line of symmetry. Excuse me. The highest or lowest point on the graph lies on the line of symmetry. And then we're talking a little bit about this a value here. If a is positive, the graph opens upwards, like this. If a is negative, the parabola opens down. So it looks like that. Changing b changes the location of the line of symmetry. It's a nice, very succinct way of putting it. It changes the location of the line of symmetry. And c is the y-intercept. Also very succinct. Not only does c move the graph up and down, which it does, but c also changes or is the y-intercept. Okay, it is the y-intercept. Okay, all right. So now I'm going to get you to do the questions in your textbook that follow this, and that is on page 360, numbers 1 to 6. So just a little overview. Number 1, you're going to say whether or not the graph appears to be quadratic. In other words, does it look like a parabola? Some of them are tricky. Look carefully. Don't answer in a hurry. Question 2 gives you some sample functions. Are they quadratic? Sorry. So that's where you're looking for the degree. If the degree is 2, then yep, it's a quadratic. If it's not, then it's not. You should be able, you can tell without graphing these, okay? You can tell without graphing these. But if you look at those functions and you're not sure, then punch them into your graphing calculator. Punch them into Desmos and see whether or not it's a parabola. Question 3 asks you to find the y-intercept for any quadratic function that was a number 2. Number 4 asks why a must not be 0. If you listen carefully during this lesson, I did tell you. Number 5 just asks, does the parabola open up or down? You don't have to graph these on your graphing calculator Desmos. By looking at the functions, you should be able to answer that. Number 6 gives you a table of values. It says without graphing, state whether or not the parabola opens up or down. So what you want to do with number 6 is you want to look at the y values. Okay? If the y values go up and up, and then start to go back down and down, then you're looking at a parabola that's pointing down. If you're looking at y values that are going down and then start to go up, then you're looking at a parabola that points upwards. Okay? You should be able to do the questions on page 360 now. So go ahead and do that. And next class, you'll be looking at solving a quadratic equation by graphing.